Good day, my name is Peter Lucas. This is my contact details over there, and I will be giving you a basic presentation on multimeters. The first thing that we need to establish is what is a multimeter and where is it basically used in industry. Multimeter is a combination of different types of meters, and what you get inside of it is basically a voltmeter, an impedance meter, and diode test facilities inside of it. It is used in the electrical industry by tradesmen, electricians, electronic technicians, electrical service technicians, electrical and electronic service engineers. With this presentation, we have three objectives in mind. The first objective that we want to discuss is the safety aspect of multimeters. The second objective will be the functionality of multimeters. And the third objective is when we do a little bit of practical application of multimeters. First fundamental that we need to discuss is the aspect of safety around multimeters. So when we buy a multimeter, irrespective if it is a brand new multimeter or a second-hand one, we need to take certain things into consideration. Multimeters come in two formats. One is an analog version of the multimeter, and two is a digital version of the multimeter. The digital version of the multimeter looks like this. It's got a digital display, and it's got one button that basically is used for turning to the different functions. And at the bottom you will find where you plug in your test leads. When we talk about multimeters, we need to look at the condition of the case. This is the outside of the multimeter. What is important about this is that if there's any cracks on it, it is unsafe to use. When we plug in the multimeter to an energized electrical system, that power goes through the multimeter and exposes you to an electrical shock. That is why it's fundamentally important that there needs to be no metal parts sticking out on the sides of the multimeter. The second part of the multimeter is the display. The display needs to be visible so that you can actually see what's actually displayed. The third part is the cables that hook up the multimeter. The third aspect that we need to take into consideration is the condition of your cables or your test leads. They need to have no wires sticking out on the side of the cable through the insulation of the cable. The tips need to be nice and sharp to prevent you from shorting out PC boards and PC tracks. And also they need to be marked. And I will demonstrate on the table the markings that needs to be on these cables. The other aspect that's also very important is that multimeters have been put into certain categories by the IEC. This is the international regulation and standard. So the categories that we get is category 1 to 4. Category 1 is the lowest level and category 4 is the highest level. Category 1 multimeters and test leads can only be used on low voltage. Category 2 is good enough for single phase application. Category 3 and 4 is for high energy fixed wiring applications. If you do buy a multimeter and test leads, please try and ensure that you buy a test lead and multimeter combination in the category 3 and 4 section. This will ensure you that you have quality cable and quality multimeter. As we've just discussed the safety of multimeters, here's a practical example of multimeters. The first one that we will be looking at is the Fluke 87. As you can see, the display is clearly marked. Function button is working, and at the bottom where the probes actually gets plugged into, you can see the category 3 and 4 This is our second one that we are looking at. This one is also looks similar to the first one. As you can see, it's got the same amount of facilities as the first one. Although this is our cheaper multimeter, it has no distinctive category markings. This one over here, which is our number 3, this one is a combination multimeter. This is a multimeter and oscilloscope all in one, which makes it much easier. Instead of carrying 2 different items, you only carry 1 item. The test lead actually gets plugged in the top, and there you can see a category 3 marking for 600 volts. Then we come to the small one over here, which is what I call a pocket multimeter. This is a category 2 multimeter, and there is clearly marked category 2. The last one that we've got here is what we call a bench multimeter. This one has got obviously much more accuracy than any of the others. The big problem that we have with this one is that the casing has been damaged, so it is not fit for using this one in the field. This is the last of our examples. This is what we call a bench multimeter. Very accurate, up to 0.2% accuracy. Unfortunately, this one is just for example purposes, and as you can see, the casing has been broken. If you look at this one, it is exposed metal parts here at the bottom, and this should be taken out of commission. The first aspect is voltage DC, which stands for direct current. The second aspect is AC, which is alternating current. And then the third one is ohms, which is for resistors. Fourth one is for diodes and transistors, which is semiconductors. And amps is for amperes. This is basically to see what is the amount of current that runs through a component. These are fundamental functions that need to be on a multimeter. Things that needs to be extras on a multimeter is, for example, the frequency, able to measure temperature, the minimum and maximum of voltages, the relativity, backlight facility, and also if it can measure capacitors. We come to the part where we have to do a practical application. We have learned how to use the multimeter safely, and now we can actually go to the point where we can implement all the safety regulations plus the knowledge that we've learned about all the functions. So we will be testing a VDC, a voltage DC, on 2 different items. We can do a test on a VAC, a voltage AC. Then we're going to have 2 resistors that we're going to test and 1 switch. We will be testing a diode, and then we'll also be doing a measurement of current on a motor. The first part that we will be testing is using the multimeter to measure DC voltage. First thing to do is to plug in your red lead into the red probe facility, black lead into the black probe facility. Using the rotisserie dial, move your rotisserie dial to the voltage DC facility. Display is clear. Negative lead onto the negative part of the battery, positive part onto the positive of the battery, and there we get our 12 volts from our little test battery, and that measures 12.88. The next one that we will be measuring is a 1.5 volt penlight battery. When we put the positive onto the positive side of the battery and the negative onto the negative side of the battery, we get a reading of 1.593. Now we need to move on to the voltage AC measurement, and what we're going to do is we're going to leave the probes in the same positions. We take our two probes, positive and negative, and we put it across the two terminals of the voltage AC supply. This calibration tool pushes out 10 volts AC RMS, and that's the reading you'll get onto the multimeter. Something extra that we can do with this supply is the fact that this calibration tool not only pushes out 10 volts AC RMS, but it also pushes out that voltage at a frequency rate of 150 Hz. So when we move to our multimeter, we can actually put our multimeter into the frequency, AC frequency facility. Once we've selected the correct function, we put our meter across the two terminals again, and we get 150 AC. The next component is a resistor. A resistor is a passive component that we use in electronic circuitry. The function of a resistor is to limit electrical flow through it. On the resistor you will find quite a few stripes of colors. Now these stripes of colors are actually marking the value of the resistor. In these two resistors there are two different set of colors. The one resistor colors are brown, black and black, and the other one is brown, red and brown. Do you know what that colors mean? I'll show you. We are now ready to actually do some measurements on the resistors. Once again, the probes stay in the same position. The function switch goes to ohms, because that is the unit of measurement for resistors. And the first resistor that we will be measuring is brown, black and black, and that should give you 10 ohms. Let's see if that's true. And there's your measurement of 10 ohms on your multimeter. The next resistor is brown, red and brown, and that should give us a reading of 120 ohms. Let's see if that's true. With 118, that's close enough. Okay, now we move on to our third and last electronic component that we need to measure in the same position when we talk about the probe configuration. And this is a diode. The diode is a semiconductor. And what does a semiconductor consist of? It consists of two layers, P-type material and N-type material, and a small barrier in between is called the depletion layer. When we measure the diode, we need to measure it in two formats. One is forward bias and the other one is reverse bias. When we take the positive meter probe, we put it on the positive side of the diode, which is the anode, and the negative of the meter probe onto the negative side, which is the cathode. That is called forward bias. And there should be a reading on the multimeter that indicates there should be a reading of 0.6 of a volt. That is enough to switch the diode on. When we reverse the probes, we are putting the negative multimeter probe onto the positive side of the diode and the positive meter probe onto the negative side of the diode. That is called the reverse bias. There should be no conduction, absolutely nothing. And as the meter indicates, there's absolutely nothing going on. So a diode only allows current to flow in one direction and blocks it in the opposite direction. The last measurement that we're going to do today is measuring current. We want to know how much current flows through, or electricity flows through, a circuit, and this is going to be the method that you're going to use to actually measure that amount of current that flows through a component or circuit. Now, with all the previous measurements, we left the positive probe into the positive connection on the multimeter and the negative on the negative connection. With measuring current, this is a little bit more dangerous, and what we need to do is we need to take the positive test lead and put it into the ampere facility, either in amps or milliamps. For this demonstration, we'll leave it into the amps facility. We will use one of the motors over here. Here's a big one and a small one, and we're going to have a power supply. So we've changed the multimeter connections, we've switched the multimeter over to the amp facility, and now we're going to hook it up. Positive of the battery onto the positive of the motor. The negative of the battery goes onto the one lead of the multimeter, and the other part of the multimeter is going to close the circuit for us. At the moment, the circuit is open, so there's no current flow. As soon as I connect these two, motor will start and there will be a reading on the multimeter. This motor draws 160 milliamps. With that knowledge, we can determine if there is a problem with the circuit or if there is a problem with the motor. If we know what is the kilowatts or watts, which is actually the output of the motor. With that type of information, we can start with circuit analysis. Just to recap everything, this brings us to the conclusion of our lesson on basic multimeters. Let's have a recap on what we've learned today. 1, we've learned where we use multimeters, we've learned what is multimeters and who is actually using them. And that brings us to the objectives of today and the lesson. 1 was the safety aspect, and what did we learn there? We learned about the multimeter's condition. When we purchase a brand new one or we buy a second-hand one, do we want an analog one or do we want a digital multimeter? As I've said before, I would prefer that you actually make use of a digital multimeter. They are much more accurate and relevant to the equipment that gets fixed today. The condition of the multimeter is very important because when you use the multimeter on a live or energized circuit, you're actually inducing that voltage or current into the meter or through the meter. So that makes it very important to have no metal parts or wires or any crack cases onto the casing. If you do get into contact with that, you might get a shock. So very important is the condition of the multimeter's casing. What's also very important is the condition of the multimeter's test leads. There needs to be no protruding wires on the leads. And as I've mentioned before also, there needs to be a nice sharp point on the tip of the multimeters. When it comes to the test lead, 3 things that we need to remember. 1 is the category marking on the multimeter lead. 2, the condition of the lead itself, there needs to be no wires sticking out on the side. And 3, you need to have a nice sharp point that you actually use on the multimeter lead. If you do find that the point on the test lead is not sharp enough, please do decommission it. The third important thing that we've also learned about the safety aspects around multimeters and the multimeter leads are the category 1 to 4 is the markings on the multimeter lead or on the multimeter, and then this needs to be clearly marked as the voltage and the category.